most minute switch is the MOSFET. The MOSFET controls the electrical current flowing between one contact, known as the source, and another known as the drain, by applying electrical voltage at a third terminal known as the gate. By modifying the electrical voltage applied to the gate, a conducting channel can be made to appear or disappear, allowing the device to be switched on or off. The MOSFET is manufactured in a silicon substrate, one of the most prolific materials in the Earth's crust. The advantages of using a semiconductor material are the following. Firstly, we can change its conduction capabilities by the controlled addition of impurity atoms. Secondly, it can have charged particles of different electrical signs, according to the type of impurity added. These particles are called electrons and holes. Electrons having a negative electrical charge, and holes having a positive charge. The final advantage is that in the same small piece of semiconductor, we can create regions with different types of impurity. If we manufacture a structure with regions alternating the two types of impurity, we can isolate the charges of one sign from charges of the opposite sign. Barriers between the regions appear, preventing the charge from flowing from one region to the other. In this situation, there is no electrical current. A similar phenomenon takes place when we want to move a liquid between two containers. Even if the containers were placed at different heights, the barrier would prevent the liquid from flowing between them. In order to have a flow between the containers, the barrier must be lowered. That's the role of the gate contact in the MOSFET, to lower the barrier. The gate contact is made by using a highly conductive material separated from the semiconductor by an insulator. By applying a suitable voltage at the gate, the electrical charge can be attracted from the source. As a result, the barriers preventing the passage of the electrical charge are lowered, allowing the current to flow from the source to the drain. Under these conditions, the device behaves like a switch in its on state. If the voltage is not high enough to lower the barrier, there's no current, and the device behaves like a switch in its off state. There are two types of MOSFET, depending on the sign of the electrical charge flowing through it: NMOS and PMOS. In the first, the electrical current consists of electrons. In the second, it consists of holes. CMOS technology uses both types of MOSFET. The basic cell in this technology behaves like a pair of switches acting in complementary fashion. The name CMOS, complementary MOSFET, originates from this. Today's processors are manufactured by combining billions of similar structures.